Okay. So if you have any doubts in the programming concepts or the Arduino, the timers, or all those things, you can ask. If you want me to demonstrate anything, you can ask. Otherwise, if you want me to help you do something, that is also fine. If you want to do something yourself and you want me to guide, within the syllabus of the what have been taught, if you want me to help you do that, that's also fine. You can share your screen and I'll help you do it. If you want to try out something with the things that you have learned, you can also try that. Okay. Anybody, any questions or any suggestions on what we discuss?
Yes, please.
Uh, yeah, do you have any suggestions or on what we should discuss or something like that?
Um, so what I noticed is I went to that GitHub link you had shared with us a couple of sessions back. You know, the one you have made for the in-campus lab.
Yeah.
I was looking through some of the projects over there, and it seems like they are based entirely on the STM32 itself, right?
The board is STM32, but you also have some exercises that uses Arduino framework. So we will write code in Arduino and run it in an STM board, and there were some exercises that we do it in the STM framework, STM HAL itself. So two kinds of exercises are there.
So, do you think it is possible for us to do some HAL-based exercises properly before, while we have these live sessions going, get us some practice for that?
Okay, we could discuss some of the HAL things, but the thing is, uh, this walkway doesn't support timers in HAL, like the STM boards. So timers were not supported in the walkway for the STM boards. That's why we kind of cover the timers. So if you see the UART and so walkway has these limitations. So now, so hardware, yeah, let me show this.
So, how would we
So
be handling it during the lab itself?
we will have a physical board in the lab. We won't be using walkway, right? So here, uh, in the supported hardware, STM, this board is there, right? Yeah. So here, these timers are not available here. STM timers. That's why we kind of covered timers in Arduino. It has similar functionalities, but with the HAL code. If you see that lab manual, this one here, there are three things. One is fully based on timers, and one is based on UART. So basically, UART is just GPIO and timers. This also involves some amount of GPIO things. Since this doesn't have uh, that support, you can try out GPIO exercises. That's why we gave the LED blink kind of exercises in the portal. I think one question was for the LED blink. So that is kind of supported, and we don't wanted to try out any other things. But you can also try out these things. Uh, GPIO, USRT, cell serial, right? This you can try out with HAL also, printing something, the thing, and ABC. This for peripherals. You can try connecting the peripherals and do these things. Okay.
Sorry, could you please show how we would use HAL inside the walkway?
We don't directly use Valkyrie, right? So we should write our code in the HTML IDE. I think one of these exercises was there, right? Where you copy paste the main.c and the main.h in the thing. There was an exercise.
Right, that was straightforward because we just connect LEDs and then we do use the toggle function and the delay, and nothing else was used. So I think that worked out okay.
Yeah, so GPIO, what you have, write, read, and toggle basically, right? Those three were the functionalities that you have in GPIO in output mode. In input mode, you can try it in input mode, reading that, right? That's part of the read. And then you can try this one, external interrupt maybe. External interrupt is like the button based thing. I think one of these exercises you could try out if you want to. It's see here, this one. Here, this is that's the button interrupt exercise was there. You could try out that one. This this code is actually written for the and another board which is not present in Walktree, which we have physically. But the similar things you can do it in the that also. Here the configuration you have to find the user button pin for that particular STM board that is available through the datasheet, and you can enable these similar settings in the STM board and put it in the work, the main.h and main.c files. So the main idea is same. We cannot do pretty much with the STM board in Walktree. So we can like work with GPIO. I think that is very pretty straightforward if you use HAL. Only you have to learn how to configure the things. So the configuration part, that's why we have given just only one exercises as a GRPA for that. How to set up the do the configuration. So let me try this. Yeah. The coding part will be very easy only. So if you see, let me log in.
So what I feel is that even for the in-campus lab, you will be having us generate this configuration main.c, main.h in the MX, and then you will bring us the board, or or we will go to the board, and then compilation. How we would be doing something is there for that as well, maybe.
Hello, Madhu. Yeah. So I think my laptop got stuck and I stopped.
Hello.
Yeah, Mr.
Sir, I have a question.
Yeah.
Sir, while programming a microcontroller, what things should I take care of so that the flash memory will not running out?
Yeah. So usually, you should be limiting your code size, the program size, the number of files involved in your uh, code, program code, right? So it's also the choice of the microcontroller. So some microcontroller have long, more flash memory, like the program storage. Some has less program storage. In that case, uh, it depends upon the libraries that you use usually. So if you have more libraries to and you are using more libraries in your code, that might require more program storage, right? So sometimes those libraries may not be needed for the task that you are doing. For example, what can be done with Arduino libraries can also be done with AVR based libraries, right? Which will be lesser in size. So if you have size limitation and if you want to run that code there, you want to try out a uh, kind of slimmer framework in some sense, right? That's what you have to try. Otherwise, you have to opt for a different microcontroller with more space if you want uh, more memory. Like, right?
So sir, what microcontroller should I choose?
So there are like very lots of microcontrollers available. So if you go and search in any sites, if you want to buy online, you can look at the specifications. So first you have to you can try by compiling the code if you are wanting to run a particular brand or like ESP or Arduino. Most of the different the code will be compatible with the other boards also. What you can try is, so if you are uh, you have to check how much your program takes instead of directly uploading it to the microcontroller. You can try with the compiler itself. The IDE itself will tell you this program space is uh, like going out for this particular board. And also in the different IDEs, for example, in the Arduino, you will have different boards, right? So you can choose that boards. So there are different boards that are available in the Arduino IDE also, and the STM also have different boards. You can check all those boards with the manufacturer that you are interested in and see the specifications from that. And that's how you find your what the appropriate thing that you need. If you are like you can try it in the IDE first. Your code that you want to run, uh, it may be needing more libraries than you expect. Those kind of things will be there.
Okay, sir. Sir, is there any way to extend the flash size of a microcontroller by putting external storage or something else?
External storage, I am not sure about that, whether you could do that in an easy manner. It might be complicated. I am not sure about it. Okay.
Okay, sir.
Um,
Yeah.
Excuse me, are you showing us something?
Um, no, not yet. So, yeah, now I am sharing the screen. So, you asked me about the IDE, this one, right? So, let me show how to create a project and things. Usually, we start with this one. So, this will kind of download the available data on different ports, basically, like kind of sync up. and the project explorer will open up. Yeah, this is the target selector. So the target selector will consist of different boards that we have. So here we can go to the board selector if you have a specific board at your hand, or in case of Botby, it is a Nucleo. There are two Nucleo boards are there. One is this one, so we can choose this one. So I'll select and next. Mm, uh, let's call it interrupt button interrupt. Now this will create an IOC file, which is an input output configuration file where we kind of set the things. So it starts with the default uh, uh, configuration. So I am going with that. Okay.
This is your CubeMX, right?
No, the cube ID. So cube ID, the target selector will open up. So the target selector will consist of these boards. This is cube ID. Cube ID is different from CubeMX. CubeMX is a tool. Cube ID is a set of tools which also include CubeMX. So the CubeMX window will be present inside the IDE also. But the IDE also has other tools, the Explorer, the compiler, the debugger, all those things. So this is our code and microcontroller that we have. So if we want to follow the one of these, we can do a similar thing there. So here there are three LEDs. So let's first take the uh, this one. Uh, yeah. So we have the pin names here, right? So we need the uh, oops, this one. Yeah. Go to target device dots and things. So here you can find the different codes or like the different manuals related to this one. So I think we need this one. Let's check that. Yeah. So what does this contain? So this does not contain anything related to programming in that sense. I think this is about just the different um, tool chains that you can use to program and how you can program certain. That is all. So, this one. Okay. This has different things I was named pin diagram and different LEDs that are connected. Let's go to the pin diagram. Yeah. So this is the Arduino based connectors, and these are the things. Now we need to find the addresses of this. If there is a mapping, yeah, you can see where the push buttons are connected to. So you can get the pin numbers from there, right? And the LEDs. I think, this 4 LEDs, I don't think it is available there. Let's check. Yeah, four input LEDs are there, but user LED is just one. These have different usages, right? Okay, so let's do one thing. So let's start with a simple GPIO thing. Let's have one LED and a push button. And try to use GPIO, all GPIO for doing this. For programming, we have, yeah, this is the STM hall. This has a description of the different hall functions and stuff for the STM-Z0 series. So that's it. Let's connect this and pull up more. This is our connection. So for this we have to write the hall code. For all GPIO, we can go to this one, go to this GPIO section. Here is where we will see the different things. So this init things are the modes which will be kind of taken care by the MX, right? We are like much worried about these initialization things. The code will be generated by the MX itself. The thing that we are worried about is this one, the read, write, and this is multi-state pins for different functionalities and functionalities. Here we have the toggle pin. These three functions we can use, and these are for external interrupt handlers. All these functions is also we'll look into it how we can. For now, we are not using interrupts. I hope this is quite uh, easily describable. As you have seen the interrupts in the Arduino, you can uh, guess what this means. This is GPIO external interrupt falling callback. So in external interrupt, there are different types in which we can set the interrupts, right? There can be when the state changes from low to high, we can set. When it goes from high to low, we can set an interrupt. So those kind of things. So this callback means uh, callback is like kind of handler. That function will get called during that time. So that's what we will usually define. So here in this case also, in the interrupt this function, this one is triggered when the external interrupt occurs. These are the different callbacks that we need. This is the time period elapsed callback. This callback we will use for the call the debouncing things. Here this has been used. So during external interrupt, we will update the thing. So we will change something. That's the idea. So now let's go with this one and this one and this one. How we will proceed. So first we have to find the this names for the pins that we selected here. Okay. So how do we find the corresponding pin name? So that will be available in this documentation over here. Uh, Arduino D13. So Arduino D13 is connected to PA5. Right? You can search with the Arduino name. So this is that PA5. So we'll go here, PA5. It's actually connected to an internal LED. So it's kind of already configured with that. You can see this system GPA. These are the things that have been set. Then, to GPA output. So we have it here in the output. Right? And we have D12, which is PA6. Right? This one will have the input mode. So you can see that it's here. You can set more configuration in that by clicking here. Here in input we have this pull-up mode, so we can call it. You can even name this pin here itself, button pin. So this helps in the code generation actually. Let me show that also. This is P6. Here this is LED pin. Configure this. Let me generate code. So when you save this, the configuration related to that will be generated. So yeah. So it generates code, and you can see there will be main.h and this source.h. The main.c, you can now find the initialization code. The GPU init function is getting called, and also other things that are getting called. This is the LED pin. LED pin was set up for the output mode, and the button pin was set up for the GPU. So if you don't set that name, these names won't be like this. So we can actually set the name so that it will define the names for us. These button pin stuff, it will use that names instead of this names. So if you see the main.h, it will be easy for us to these things. It usually names these things. Right? So with that, for this one. Is V2. So it will actually generate that things. So you can use, instead of using the pin name as PA5, PA6 now, you can directly use the pin uh, with the name that is given here, the LED pin. So this one we can use instead of using that, these names we can use. So that's the advantage of it. Okay. So now we have generated this code. So now in the, so there are different sections that are present, right? So we just want, they are just reading the state and doing this. So that we will usually do in the while loop. So what we are going to do is read the input from the uh, button pin. So which is we will be using this one. Here we have to uh, mention the GPIO name, which the port name, the pin name, and the state. So this is what we do. So to enable that, right pin, GPIO port name, GPIO, which is PAF5, right? So GPIO A, and then we have the LED. Uh, we have it LED. We can just name it LED. Then it will be LED pin. Now it is LED pin. LED. And also you can see the port name also. It's actually named it as the LED pin GPIO port. We could have used this also. We don't need to remember the which port that it is present after naming this. We'll just use this LED pin pin. And the state we could have said 1. So now this will just turn on this. Similarly, we instead of doing that, we could do read pin. So that is the function name for that. All GPU read pin. We just use the pin name and stuff. So here instead of LED, we can use button. To account for the pull-up logic, I am inverting this. To account for the pull-up logic. So this is the one line that we need to do for us. So here in this one, we'll delete this file and add make.c and the make.h file. All the other library files will be actually included by the work itself, so we don't need to upload every files. We need these two one. Let's copy this one. This is main.c. This is main.h. Now let's run this. Oops. I think we need to include this one. Okay. This is the thing that it requires. Okay. In the default settings, it is using some BSP things. So there is the hall, and there is also there's something called as BSP, which is another kind of uh, what do you say, a layer of writing program. It's a more higher level than hall. So it is having some codes over here. Maybe I'll remove that BSP related parts. That should be sufficient. So the main data child is maybe in the configuration when you create a new project, if you don't go with the default configuration, you won't get that PSP things. Okay. Too many arguments. Okay. Read we have given the state also. Yeah. If you have a STM board in place, you could just compile using the STM ID and upload code using that. You don't need what we do this. You could also use only CubeMX and Visual Studio Code to write the generate code and simulate using what we do. Okay, that will be so. I think these names are not different. It is not different. You have raised a hand. It's different to work. It's fine. It's fine. E13 into this PV6. Simple. It's fine. Configuration. E6. Let's try the
Excuse me.
yeah.
Maybe the way we are giving the argument is not working. Instead of tilde, maybe you could use the exclamation mark. Would that help in some way?
Let's try this. Okay, let's okay. This variable setter there. Just 0 and 1. Yeah. Okay. Still this bitwise not not sure. See what's searching symbols. Okay, this is bitwise not operation. and this bitwise complement. So in the sense, it will turn on flip every bits. Okay, this is a logical part, which means all the values. Okay, operator with it. So the idea is, yeah, yeah. So this tilde symbol, what it does is it will flip every bits in a single value. But this not one uh, will be logical in the sense any number greater than one not will give you zero, and it works like that. But for till, uh, it maybe I think it's due to the maybe if there is some number like this, maybe negative zero. I'm not sure how that is even said. I'm not sure of the initial state maybe, or the value that is coming from the read bit. Yeah, that might be the reason. I'm not sure. Is this a boolean value or some uh, other value? That may be the reason. So that okay. Now we can understand this idea of how we can set this. So not this one. Uh, if you have any number like 1001, it will change it into 0. But this one, if you have that number, what it will do is it will flip the bits. It does this. That is the difference between these two operators. This is logical and this is bitwise. We need the logical operator here. Okay. So now let's uh, try adding a serial communication. UART. So what do we have here? I think here we instead of can we reset this BSP. Whatever the BSP parts will turn off these things. This, yeah. Now I think this is better. We don't have the BSP parts and we just use this. Maybe we'll rename this to just button and now we need what? Right? So for printing anything, we have let's check whether it is supported or keywords. What is supported? Okay. So let's try that. We have the sort one. So enable this. Okay, set the baud rate. Yes, I think the default settings is fine. Okay. Yeah. So with that, we can generate the code. The code is generated. So we'll update it here. So main one. Main dot yeah, here now we don't need this additional LED GPIO port and LED pin, button GPIO port and button pin. Yeah. And we will just go to the UART. So here we can use this to send data. Let's go to the UART transmit. So transmit is the sending function, which is basically serial println. So here we will be able to transmit characters. So here that characters we share by a buffer, a character array, which is we call as a buffer. Right. So this we will be using this one. So yeah, transmit. So in this buffer, we'll just print this state. Like we can have two strings, which we can have here as a local variable in the main function. Char uh, on is equal to an array of equal to of. Maybe we'll add a slash n character. Okay. Now what we'll transmit based on the state of this one, we can change these things. So here I'll have using an int uh, state return state if I am using if conditions to transmit different messages. So for transmit, what are the arguments? We need a UART handle. Okay, UART handle is the uh, UART port that we are using, which is UART one. USR one, which we are using, and the data pointer to the data buffer, which is in this case on, and the on signal has size of three bytes, it's including this character. And type timeout, for timeout, I think we use a constant called all max timeout, which is so you can find here. There's this all max delay. You can use that as the time. Yeah. Transmitting else transmit off, which has 4 bytes with that. Now let's see this one. How it is going. Oops. Here right. Okay. Let's take it.
And the tilde is still there.
Oops. Yep. Thank you. Yeah, again, this one. This one. You have to copy this code back and forth if you want to change the configuration. Okay, here we missed a speaker.
Also, in our size, is the null byte included? The null bit?
You don't need to import the null byte actually, because we uh, because we are specifying the size, right? So it will just set that many characters. So it won't go beyond that. Since we are specifying this, okay, what transmit is not there. Wow, it's correct. Yeah, Divyanshu. Divyanshu, you have it up. Okay, so that. The what things are written over here. I think this should be there. We should have included all these all files, right? Because we are including that all. Sure, there are what is supported. We have examples of using what. Check. They are using what. Okay. This is what two. This is currently using that. We will try with the what two. So this. Okay. Save. I think before doing that, we should copy our this code. Copy this there. Domain.c. Then change the configuration and share it. Now generate code. Project. Now code is updated. Now it's back here. In that case, okay, we have okay. What handler is HUart. So we should do that. HUart. This is the pointer to that UART handler. Just this one. So UART to make this happen. This is fine. This should work.
So, are we expecting the serial monitor to get initialized on its own?
Yeah, it will, by default, if the inward signal is there, what we will give us the serial monitor. So, for example, here it said hello with you, right? It will pop up. So, we are expecting that to pop up saying on or off messages. Okay, here saying what something. Okay, let's see the differences. If there is some other things that is included here, all is included. Okay, that much all is included. Okay, maybe we put it this way that making difference. I'm not sure. Other things are standard library only. Then this transmit should be available, right? Same function here. This is
Just in case, is that USART transmit or UART?
UART. Oh, oops, yeah. Okay, yeah, we have USART here. Okay, we should have gone here. I think USART is not supported here. Oh, USART is there. Right? Okay, here we are using what? So this one. There is a word driver and USART driver. USART is not supported in work. That's why we are using the UART. Yeah. Okay. Now we need a UART. Still here they are using USART. Right? It is not. Okay. Same thing, right? Okay. I'm using asynchronous mode. The configuration. Okay. That is fine. USART is the synchronous mode. We are using asynchronous mode. That is correct. Okay. UART handler typed. What was the error here? Compatible. Is it was a pointer or
I think there was an address notation and ampersand was there
no? I think
where
it
you
was a
picked it
pointer.
from.
Let's see. Okay, they are using just printf function from the standard. They are not using transmit. You are transmit here. They are just using printf to transmit this. Okay, here it is printf is there. Okay, they have to pass the address here. Hopefully this will work. seeing the world. Okay, okay, we are not seeing the world here. This is needed for the printf function. Okay, I think they are mimicking the UART thing. Okay, the printf will write to a particular file. So if file is there transmitting, this causes both error and the thing to go to UART while using this mode. This should work here also, right? Here, sections. There. Now this should be there. So it's to initialized, initialized, GPU initialized, UART initialized. Is that what's the configuration? Let's check that. Similar configuration, right? Just go to the side by side and check them. This part is there, the GPU part. Okay, okay, this part is not there. Anything would be, we didn't enable something. These are for the GPU, right? That is there in the GPIO unit. Yeah, these things are there here. Okay, they are actually enabling these two pins here, pin 2 and 3 for the uh, UART, assigning that pins for the GPIO. Yep, UART is enabled, right? Okay, set, set right. So was the code not generated properly? This is this. Still not. Maybe we'll try adding these things there. Should have been generated by the code. Yeah, now it is working. I think it needed to be these pins needed to be configured for this. Not sure. Yeah. When you press on will be transmitted, and when you press off will be transmitted. So let's see if there is any settings that does this. Okay. Still doesn't produce that kind of code here. Not sure about this. They are manually setting those pins for this. Setting to GPU. Not sure about this part. How this is actually working in Wakvi. Because in actual code, this wasn't necessary to give an additional configuration like this.
Sorry, what is that you have just added manually?
So this thing is basically what it is doing is it's enabling this in an alternate function UART mode. But actually we have that here, and I'm not sure why this part is not generated by CubeMX. CubeMX should have generated if that is needed. So you can see this, right? It is setting that pin to that. Here, what is in the all coordinate, right? It's in that function. MX sort what this function. This is function. So that is basically enabling this ports for the alternate functions. Here this is alternate function is there, right? These are the different alternate function. So they are enabling it for UR2. The Pego function. So these pins are actually configured here. Let's see what is the configuration. Alternate function push pull mode. No pull frequency. Yeah. Restrict CPU. Here it is not shown. Let's try with this. Change this to UART. Then I think UART is disabling. Yeah. Now when we do this. Oh, now it is changed. The RX and TX pins. This should be the thing. GPIO EA2 configuration is alternate function push pull. These things are there. Maximum speed low, no pull. This thing. Okay. The settings are there, but I'm not sure why that is not generated by QBMX as in here. It's not generated by QBMX over here.
Although over there we see it under the void MX thing. So MX is the domain of CubeMX and it should be doing it, right?
So it should be having that this initialization if it is needed. That's what I'm okay. Maybe it is being done in some other uh, thing. I'm not sure because it's it should do this right here in this code is being done by that, but here it is not generated. All the other things are set similar, same only the configuration. Only it is that this particular thing is not being generated. Not sure. Uh, okay, maybe I think the usual settings will only generate the things. It won't be connecting it to the UART. If it's so, we should be able to set that up, right? Mm, alternate function UART.
Sorry, there seems to be some HAL RCC clock something something top line.
This one. This one.
Yes, that one.
That is enabling the clock for that particular pin. I think you can find similar to that here. GPIO in it. They are initializing that, right? So that is enabling the GPIO clock just in case if it is not enabled. Since we are initializing this, uh, so the point is this code is being generated here. If it is here, it works, and that code is not being generated by this one, QMX. That was the
By the way, it also says over there that one is TX and one is RX in the
yeah. Here also
vocality.
you can see this, right? One is signal UART is there, TX and RX. There is these two pins. Basically PA2 and PA3, PA2 and PA3. Uh, this is the correct one, right? You can also see that being in GPU settings also. It is configured here, but the code regarding this configuration doesn't show up anywhere in the main.c or the main.h. Or maybe is it in the main.h? I'm not sure. Mm, let's search if it is being called any. Or maybe it's maybe due to a version difference. It might be the case. I think the version of HAL that Walkbee uses and the version of HAL we use might be different. Maybe these things were will be taken care by another function inside itself. I think if we go by the default configuration. I think if we use, let me change this for TX, and now we can see the UART being modified P3 and 4. If I do this, let's see main.c. Still, I don't see any initialization over here. I think it might be due to the version difference uh, of the HAL libraries that these people are using. Maybe the HAL that we are using will handle that internally. I am not sure about that. Why this needed to be explicit over here when MX doesn't generate that.
Maybe the IDE would do it for us anyway. It's possible.
What?
Maybe the IDE would handle it for us when we got to that point. At the compilation stage, maybe it would be doing something to handle that part.
Yeah, that's what I am saying. That might be the difference between these things. This is the default thing, and it's not. These things are not manually generated. Let's name this TX RX.
Sorry, do we really need both TX and RX? We are
Since
just transmitting, right?
yeah, RX is not needed, but when we enable UART, both will be enabled, right? Usually, we are only using one, but UART is a peripheral, right, which supports both TX and RX. We are not reading
So
here.
it's like,
Yeah. For reading here, we need another peripheral which communicates using UART protocol. So if there is a peripheral that communicates using UART protocol, we can use that in WalkMe to do that. Okay. Let's see if this has generated anything. Still nothing. That generated anything. Okay. Yeah. So this thing you can see here, right? This part is over here. TX and RX pin configuration. It's in a different C file, a hall msp.c file, not in the main file. Yeah, I think this part they have copied into the main file there. So you want MSP in it, which is present in this file. Yep. Yeah, it's actually there, but not in main.c over here. Then we could have just used this one also. We could have just added instead of that, just add this file. Right. Yeah, that might be due to the difference in version. It is now generating it in a different file rather than in the main.c.
sorry, as you had mentioned, it seems like it is common sense while using UART to to initialize both the TX and RX. Is that why we do them together?
Yeah, even if you don't initialize the RX part now, for this program it will be fine. You just have to remove this GPIO pin 3 from this code, the configuration. That wouldn't affect the functioning of this, but you can manually remove that, right, if you don't want that configuration. I just have to. So this MX thing is generating this in a new file. Rename. This is being very slow. Wait, it's getting stuck. I'm not sure. Spacing. Space is being slow. Okay. Yeah. Now we can use this one directly. This one over here. This is working very slow. See, this is not needed. This part is not needed in main.c. This module page is getting very slow now. Okay, maybe due to the simulation. Yeah, the simulation is running for a long time. Okay, that's why the page is getting slow. Now this is fine.
So we have taken out that part from the main.c and uploaded the file which has it, and we are checking if that works.
Okay.
Does it work?
It seems, yeah, these pin definitions, right? I think there should be another file, header file, which that pin definitions are there. These pin definitions. The new TXRX is not defined over here. So okay, let's find where it is defined. ATX is defined over here, right? The new generated main.h. So this main.h also we have to update. Yeah, now TX and RX are defined. It's just that it requires some uh, it is generating the code in multiple files. So that particular configuration it is generating in this file. So we actually need that file also for this example. It should work fine. Yeah, we can just use the MX generated code in that. Right.
So if we supply the right file, it will work anyway.
Yeah. So yeah, here in that example where they have what we the example given, these things were initialized as the part of this one. But this MX is generating that particular part in a different file. So it may be due to the version difference. Maybe the previous versions might have generated it in the same file. The current versions, it is generating it in the different file in the HAL MSB init. This HAL MSB.c. This configuration, the one GPIO configuration, is in a different file. So that is also needed there. So to use UART there, we need these three files: main.c, main.h, and this C file. I think this will have some interrupt service routines. So if we are adding any interrupt service routine, I think we need to upload this file also because it's being split over multiple files. Okay, so in that case, if we are using an external interrupt in any pin, let's go with PA7. I hope PA7 is a good pin. Yeah, D11. So PA7 to input, and let's initialize external interrupt with this. I think okay. Wait, this is only EPIO external interrupt. So this EXTI mode will be external interrupt. Okay. So now we can call this interrupt button, and we can enable external interrupts for line 14 to 15. This is external interrupt 7 for pin 7. So if we generate code now, I think certain things will be added to the it.cc file also. So yeah, there are certain other things that has been added here. Uh, You can see the interrupt handler has been added here for that line 15 to this one. So here the interrupt button, this one is getting called. The IRQ handler for this is getting called. So this is what we need to implement basically. Mm, This we have to implement into. So to run this way, we need this one also. Okay, this for this meeting. Okay, this is the handler. This will internally call this particular callback function. So we need to define this function. The external interrupt exti exti. We have to define its configurations and all taken care. We have to define the callback. Oops. Yeah, come last. API. So API will have the different functions. Yeah, interrupt, simple, both of them. Register callback. This is square. This is what we have to do. External interrupt handler, user callback identifier, and these things. So this one, I think here it is also given. Yeah. Here you can see the external interrupt example. This callback is being used. GPIO external interrupts. This is configuration. I think the callbacks are here. Yeah, in GPA, external interrupt, racing callback. We can set up a racing callback. So this function we have to define. There is a racing callback and a falling callback. So to define that, we can go to main.c. In this part, we can define that callback over here. Yeah. And with the GPIO bit, this one. So when this is rising, we can say if let's first copy the main.c, main.h and all our files. H. This one also they need to add. So, I'll add a new file first. Using Workbee this way is bit difficult.
I think it is much easier when you have the physical board, is what I feel.
Yeah. Yes. With physical code, it might be easier. In Workbee, if you have to try out, we have to go back and forth with this, right? If you have a what I think Workbee VS Code is also uh, I'm not sure how to generate the compare files. So if we try build, mm, target name, it's building. Yeah, this ELF file. Okay, we might be able to easily use this with VS Code Workbee also. But that for VS Code, this will generate this ELF file which we might need to configure. I think instead of using that, it will be easier. Let's see whether this binaries. This ELF file is generated, right? We can do it would be easier in that way. Yeah, instead of going back and forth, let me open this folder in copy path. Yeah, use this. Binaries. It's the binaries. These are not here. Debug numbers. I think these are. Where is this? It's inside the debug folder. Debug. Yeah, this file is there. So we can use that with the VS Code. Here we just have to add v.2ml. Also, yeah, let's see what we don't do. This is what we need, right? We don't have the hex file, I think. We do have a ELF file. This is what we need. This is copy paste. Yeah, this we might be able to do something with this. So ELF path must be strings. Okay, some strings, right? Where? What's that? This here itself. Diagram not just as needed. All these things are experimental. Okay, so this will come out. Let's take it. So, okay. Okay, it's working. Yeah, but the serial seems to be doing some things.
I think we got this far. That is already amazing.
Huh?
It's quite incredible that we got this far.
Yeah. Not sure about. Uh, we can. So now what we can do is instead of going back and forth, we can do the configurations in the IDE over here and do this, which will build a file project, build targets, build project, build all, build project, will build the things, and after building, we will just check this, uh, start the simulation, which we have the file here, right? So let's have the simulator over here. So we have this in local. Okay. So we will be also able to do this. And now we don't need this one. Yeah. Oops. We need only these two. Okay. Where were we? Let's go to main.c. Uh, yeah. So here we'll add the function. This one. Yeah. So what shall we do here? In our main code, mm, what are we doing? All transcript. It's just a warning. It's maybe. Yeah. So my idea is I'll have another variable over here. Uh, just invert to 0. So if invert, I will negate this. If not invert, I won't negate this. So basically, we are doing this one, right? So what we do, we don't do this. But if this invert is enabled, we will invert this. So invert, if invert, we have to invert it, else we don't invert. That is the idea. This one we cannot have inside main. Now we'll go to the global scope. Global. Yeah. We'll use here in begin 0 outside the main, and this invert we can change in here. If GPIO pin equal to interrupt button pin, if that button is being pressed, we'll invert, basically toggle this, or not equal to invert, basically equal to not this. We'll do this. Okay. This will logically invert this. So whenever the button is pressed, it will do this external interrupt. Right. So in our walkie diagram over here, this one, not this one, this one. Here we'll add another interrupt. So a button. This button is for the external interrupt. Okay. That is the pin that we used. PA7, I think. This one. This one. Okay. Now we'll generate this file. Now this is uh, uh, let's turn off bounce here. Later, I'm going to turn off bounce for simplicity here. So which means whenever we this is X-ray, there seems to be a new option that is added for this button, push button. The X-ray option was not here before. Let me do something. Not we. Okay. Show internal wiring or not. Whether that is being shown. No.
It's just made the button translucent so you can see the wires inside it. That's all.
Oh, okay. Oh, okay. That's a very minute difference. Okay, that's fine. That's just a display thing. Okay, that is fine. So in that case, so now we have turned off bounce, which means whenever I press this, it will cause a uh, rising edge, right? Because of the okay. Since we are when I release it, it will cause a rising edge, right? When I press and release the button, it will cause a rising edge. It will trigger that, and that's how this will work. So now this is on. When I press the button, now this will be off. It's been by default. And you can see when I press this. So this controls the pull up or pull down behavior. Okay. I think we should also do it here with the whole logic. This button state, we'll update the whole button state here. So that the LED will also behave in that. And we'll build. So now we start. Now the idea is when I click this, uh, yeah. Now this is off, which means the actual pull-up logic is now there. When I press this, it will turn on. When I release this, it will turn on. So the second switch that I added controls the pull-up logic. So if now I press this once, I don't have to hold it. I just press this. Okay, so nothing happened. Okay.
అక్క కాదు స్విచ్ ఆఫ్ అయినా వేరే ఫోన్ నెంబర్ నుండి కాల్ చేసావా ఏంటి అనుకున్నా.
So yeah, I think this is if you do this, the destination button state. Okay, this is not about button state. We shouldn't update the button state. Instead, we should use this is something else. Uh, Since it's button state only, right? So let's try it. Now it's on. Now it's off. The pull-up logic is working. It's not turning back on. Yeah, now it is on. So now it is in full like alternate the actual logic. So we are changing the pull-up or pull-down behavior using this. Right? This when hold this button when held, it will change the state of the LED. But by default state, the default state of the LED, we can control using this button. Okay, I think this is not being set in the pull-up mode. I think let's go to the configuration. GPIO. Yeah, here we have to set it to pull-up. Yeah, this one. Okay. Then we have to, because that button is not behaving properly. So now build control B. So STM will build the thing for us. Now this should be working. Yeah, yeah. When I click this button, basically the default value of the light will change. When I hold this button, this is due to GPIO. But when I press this button, I just have to press it. The default value of the light changes. You can see this, right? But when I hold this, you can change the state of the light. The default state you can change using this button, which is doing this using an external interrupt. But this one is doing that using GPIO, basic GPIO reading. Why this is doing this way, I'm not sure. Maybe I think this is still not sure.
You can think of it like a timing diagram. That's all it is really.
That's what we can do.
We ignore it.
Yeah. So stop it. Okay. Oops. Stop from here. Yeah. Maybe let's try this one. Maybe I think this will help. Slash arm. This might help. Or not. I am not sure. Yep, it works. So that is basically something called as carriage return. Now fine, right? So this when hold, if we hold this, it will change the state of the LED. The default state can be changed by pressing this snip. We have something. It finally feels like we have achieved something, right?
Big effort,
Yeah.
big effort to do.
Okay then. Uh, so anything else you want to ask, clarify?
Just one thing I've been meaning to ask for a while.
Hmm.
While editing code, you do something where you select a variable once and that ends up selecting all instances of the variable. How do you do that?
So in VS Code, or I think it's available in the Workday editor also. What you do is it's a shortcut called Control D. So you put, so for example, I just do this word. If I place this, modern editor will show all the occurrences. But if you want to select all the occurrences, just press Control D. It will paste this in, like, put the cursor in all those occurrences. So you can edit it all together. So it's just Control D. I think that is not available in this one. Control D deletes here, this editor. VS Code, by default, I think VS Code will also do the same, delete it. But there is, I use something called as Atom Key Map. It's actually, this is from some different editor, I think. This, that is a good thing. I think Colab also supports this one. You can just use this multi-cursor editing by using Control D. That's helpful if you want to edit multiple things together. Refactoring like this. I just want to change this pin, so I can just use this. Change that. Control D. So this shortcut is available in most of the editors, I think. Some editors may not have the shortcut. I think some editors also support multi-cursor editing through this. You can just place your cursor by control clicking it wherever you want, and then do this multi-cursor. To select the same instant, I use this Control D to select this. I think it won't be available in the default VS Code shortcuts. I use one extension called Atom Key Map. This one. This with that, you will get the Control D shortcut. I think it will be there. Not sure. Okay, fine. That's it. Anything else?
Thank you very much.
Yeah. Okay, then everyone. Thank you for being here throughout the session.
Okay, good night. Thank you.